Hello everybody, and thank you for joining me once again. We're looking at question number 2 on the 2012 Hypatia contest. That's the 11th grade level written contest. They're written the same day as the Euclid, which is the grade 12 contest, and it's sort of like a miniature version of the Euclid. It prepares you for that contest because the Euclid's quite important if you're heading off to university. So question 2, we've got 4 parts here. Only one of them's written. So let's dive into our final answer only required questions, but of course we'll write a little bit. So A part, determine the value of a plus b squared given that a squared plus b squared is equal to 24 and ab is equal to 6. Okay. Well, by this point in our education, we probably know how to expand sort of a binomial like this, a plus b squared. In fact, some of you might be able to write it out completely. But we'll go the slow route just this once. Okay. What does it mean to square things? You multiply it by itself 2 times. And then what do? We do what people tend to call FOIL. That certainly seems to be the buzzword for the last few years. So I multiply the firsts together, the outsides, the insides, and the last ones together. So the first 2 get multiplied together, the outsides get multiplied together, the insides get multiplied together, and the lasts get multiplied together. Now in my day, we used to draw this little figure, and it sort of looks like a person. So we name him George. Here's his nose, here's his face, and everything. But regardless of how you remember it, FOIL is a great acronym. If you want to remember George just because it's fun and you like drawing people's faces, that's okay too. But we multiply the firsts together, a times a squared. The outsides, a times b, so you'll get ab. The insides, b times a, which of course can be rewritten as a times b. And the lasts there, b times b squared. Okay. And we can bring that all together, a squared plus 2ab plus b squared, which is probably the first thing you should just, if you need to, of course, FOIL it, but I would recommend skipping all this. A plus b squared is just a squared plus 2ab plus b squared. Okay. And now once we've written it in this form, we see where the information they gave us fits in. Okay, so let's take a look at the information they gave us. We know a squared plus b squared is 24. Well, we've got an a squared and a b squared. We know ab is 6. Well, we've got ab. In fact, we've got 2 ab's. So I might rearrange this to make it a little more clear where these numbers are coming from. And then we have 24 plus 2 times ab. Well, ab was 6. 24 plus 12, 36. Okay. So 36 is our final answer because they just said, well, what's a plus b squared? Okay. Nothing much we need to do there. B part. If x plus y squared is 13 and x squared plus y squared is 7, determine the value of xy. So now they're giving us 2 pieces of information, just like they did last time, but asking for a different thing. And just looking ahead at C part, they're giving us another 2 pieces of information and asking us for sort of a third component there. Alright, but we'll get to C in a moment. So, x plus y squared is x squared plus 2xy plus y squared, and I just want xy. So I could rearrange and say xy is x plus y squared minus x squared plus y squared all over 2. Well, what's x plus y squared? It's 13. Minus x squared plus y squared, which is 7, all over 2, and suddenly we've got 6 over 2 is 3. Not a whole lot going on in these ones, so I would guess they're largely worth 2 marks. Final answer, and then, did you do some sort of rearrangement or calculation involving x squared plus 2xy plus y squared, that sort of thing. Okay, and C part, basically going to be the same. We wanted, I think it was JK. Yeah, we want JK. We're given J plus K, not J plus K squared. So 36 is 6 squared, but that's J plus K squared, but J plus K squared is J squared plus 2JK plus K squared. And that's J squared plus K squared plus 2JK. So that's, and what did they tell me J squared plus K squared is? It's 52. So that's 52 plus 2JK. So I would subtract 36 minus 52 is 2JK. And the difference there is, and if you need to get your calculator out, and I didn't use the calculator a whole lot in the last question, so I'll bust it out right now. 16, negative 16 is 2JK. Well, divide by 2 on both sides, negative 8 is JK. And there we go. Okay. Out of curiosity, could we figure out a way to get J squared plus K squared being equal to 52 and still having J plus K be... Oh yeah, I guess 6 and a 4, maybe? 6 and negative 4? No, that wouldn't quite work. Maybe we can't get integers. It doesn't really matter. It's just when I get a negative answer here, it throws me a little off. It shouldn't, because the theory tells me that that's the correct thing to do. I squared my 6. I subtract off my 52. Whatever's left, and it's not as though you can't have negative ones. One of J or K must be negative. Okay, that can certainly happen. This could be 8 minus 2 or something like that. It's not, but 7 minus 1? No, that wouldn't do it either, but we're close. Anyway, doesn't really matter. Nothing we need to worry about. We just wanted JK. Okay. So, yeah. So we got all our light bulb questions done. And now D part. D part's probably going to be something similar but a little harder. That tends to be how it goes on the Freyr-Galois Hypatias, is each question is sort of self-contained on one similar theme or concept. In the last question it was just a whole bunch of Pythagoras. Pythagoras' theorem to answer certain questions. In this one it seems to be manipulation of a plus b squared is a squared plus 2ab plus b squared. Okay, so I would expect something similar, and these first few questions have sort of primed us for that. So D. If m squared plus n squared is 12, and m to the fourth plus n to the fourth is 136, determine all possible values of mn. Okay, so we don't actually need to know what m and n are, just like we did with the last few. Well, what to do? So we got m to the fourth and n to the fourth. Okay. How can we do that? That's different than what we've seen, but is it really? So I know m squared plus n squared is 12. If I were to square that, it's going to be m squared squared plus 2 times these two guys, plus the last thing squared, n squared squared, which is n to the fourth. Okay, this is not immediately obvious, but it's basically just taking the a plus b squared thing that we saw in part A and that's a squared plus 2ab plus b squared.